In yesterday class, we discussed about the water softening methods, and we see the example of the water softening method. Mainly, water softening method is classified into two types: internal treatment methods and external treatment methods. And the example of the external treatment method is ion exchange process. So we see the what is the process takes place ion exchange in yesterday, and the pending is the regeneration of the ion exchange regions. Regeneration of the ion exchange regions. Okay, so before starting the ion exchange regions generation, ion exchange regeneration, just we remember the definition of the water softening method and what is external treatment ion exchange process. Okay, ma. So first of all, water softening methods. Okay, ma. Anybody define? Anybody give the definition for the water softening?
Process of removal of hardness of water.
The process of removal of hardness caused salts from the sample of the water. Process of removal of hardness caused salts from the sample of the water. So that is called water softening methods. Okay, ma, very good. How many types of water softening methods, Amma?
Two types.
Two types. Okay, ma. What are they?
Internal, external.
Internal treatment method and external treatment method. So internal treatment method means the process of water softening takes place within the boilers by adding of the chemicals. Okay, ma. Water softening method takes place before entering into the boilers. Before entering into the boilers. So that is called the external treatment method. External treatment method. So simply treatment is done before entry of the water into the boiler. Treatment is done before entry of water into the boiler. So that is called external treatment method. But as per our syllabus, we have only external treatment method, and the example of the external treatment method is the
Sir.
Corona.
Okay, ma. What are the alternative names for ion exchange process, ma? Ma, am I audible to you?
Yes, sir.
Yes, sir.
Okay, ma. What are the alternative names for ion exchange process? Okay, ma. Tell me, what are the alternative names for ion exchange process?
Demineralization of water.
And deionization of the
Deionization water.
water. Okay, ma. So these are the alternative names for the ion exchange process. So from the title, we understood that ion exchange, that means the process mainly involves the exchange of ions, not only a cations, it exchanges the both cations and anions. Okay, ma. So ion exchange process is defined as the reversible exchange of the ions in the structure of an ion exchanger to the ion in the solution that is brought contact with it. So that means whenever the ion exchanger is placed in some hot water, it can exchange the both cation exchanges and anion exchanges. Okay, ma. And the properties of the resin is mainly it is porous, insoluble, cross-linked, long chain organic polymers. Long chain organic polymers capable of exchanging ions. Okay, ma. So that means basically the resin should be porous, insoluble, cross-linked, and long chain organic polymers, and having ability to exchanging of the ions. Okay, ma. Okay, tell me how many types of exchange resins, ma?
Two types. Cation exchange and anion exchange.
Okay, ma. Cation anion exchange region. So by using cation exchange region, what are the ions or exchanges takes place, ma? By using cation exchange region, what are the ions exchange takes place?
Ca plus 2, Mg plus.
Okay, ma. Very good. Cations, calcium and magnesium. By using anion exchange regions, by using anion exchange regions, what are the ions exchange takes place, amma?
Chlorine.
Chlorine, nitrates, sulfates, carbonates, and bicarbonates. All are exchange takes place by the anion exchange resin, amma. Okay. So now we discuss about the individual cation exchange resin and anion exchange resin. So what is the representation for the cation exchange resin, amma?
RH.
RH, where R is nothing but a insoluble polymer matrix, and H plus ion can act as a exchangeable ion. Okay, ma? So this is very, very important. The representation of the cation exchange resin is RH. Okay, ma? What are the commercially available cation exchange resins, ma?
Amberlite IR 120 and Dovix 50.
Okay, ma. Amberlite IR 120 and Dovix 50 are the examples for a cation exchange resins, ma. Okay. Next, move to anion exchange resins. So anion exchange reagents. So in case of anion exchange reagent, what is the representation of anion exchange reagent, amma?
R plus OH minus.
Let's OH minus.
Okay, amma. In this case, R is equal to insoluble polymer resin, whereas the OH minus ion can act as a exchangeable ion. OH minus ion can act as a exchangeable ion. And what are the commercial names for anion exchange reagents, amma?
Amberlite 400 and Dovex 3.
Okay, ma. Amberlite 400 and Dovex 3 are the commercially available anion exchange reagents. Now we see the process. So this is about the structures of a cation exchange reagent and anion exchange reagents. In case of examination point of view, there is no need to draw the structures, but you know what is the functional group present on the cation exchange reagents and anion exchange. For cation exchange regions, we have the sulfonic acid groups. Sulfonic acid means SO3H, and exchangeable ion. H plus ion can act as a exchangeable ions. Whereas anion exchange regions are nothing but a amine groups, amine linked with the amino quaternary ammonium salts or tertiary ammonium salts. So NH2 linked with the OH minus ions. So this OH minus ions can act as a exchangeable ions. Exchangeable ions. Okay, now see the process. So before watch the process, first we see the diagram. So this is the diagram for a overall ion exchange process. So in this case, there are two columns. The first column containing a cation exchanger and second column containing a anion exchanger. So initially the hard water is enters into the first column cation exchanger and filtered from the cationic hardness. After that, it enters into a anion exchanger and filtered from the anionic hardness. Okay, so these are the overall diagram for a ion exchange process.
Sir,
Now
we
we see
can't
the
see diagram.
equations.
Sir, we can't see the diagram.
Now it is visible, Amma?
No, sir.
Now it is okay. Again, I
Yes,
share
sir.
the diagram.
Yes, sir. Yes, sir. Yes, sir.
Okay, Amma? So this is the overall diagram for a ion exchange process. In this ion exchange process, there is a two columns. One is the cation exchanger column, and second one is the anion exchanger column. So from the cation exchanger column, it removes all the cations present in the water sample. That means cationic hardness. Whereas anion exchanger column, it removes all the anions from the sample of the water. That means anionic hardness. The resultant water containing the pH value is exactly 7. So that's why this water is called as deionized water or demineralized water. Now we see the equations. So initially we said that the hard water is enters into a cation exchange regions. Cation exchange region. I think all of you know what is the representation for a cation exchange region. So what is the representation for cation exchange region, Amma? RH. So see the equation. So there is a cation exchange region, and that cation exchange region is treated with the hard water containing a cationic hardness. So generally cationic hardness means whether it is temporary or permanent hardness. Simply said that the salts of calcium and magnesium. So the cationic hardness is nothing but either calcium ions or magnesium ions. So initially we consider the calcium ions. So that cation exchange region is treated with the hard water, and what happens that exchangeable H plus ions exchange from the resin, and finally that resin is captured with a cationic hardness and releasing of the H plus ions. So the product is R2Ca. By balancing the chemical equation, we react 2 moles of the cation exchange resin RH with calcium plus 2 to give a R2Ca and releasing of the 2 moles of the H plus ions. 2 moles of the H plus ions. Okay, in place of calcium, if you consider magnesium, so why? Because magnesium also one type of the cationic hardness. When it is reacts with the cation exchanger, again it gives a R2Mg. R2Mg. That means the resin is captured with a magnesium ions. So by balancing the chemical equation, 2 moles of the RH reacts with the magnesium ions to give a R2Mg, and finally it gives a 2 moles of H plus ions. Because of the releasing ions H plus ions present in the resultant water, presence of H plus ions, it shows a lower pH values. Why? Because pH is inversely proportional to concentration of the H plus ions. So presence of the H plus ions, the resultant water shows a lower pH values. So after the cation exchanger, then water enters into a anion exchanger. What is the representation for anion exchanger, Amma?
ROH.
So see the second part of the equation. So this is nothing but a anion exchanger and reacts with a hard water containing a anionic hardness. So this resin ROH reacts with a chlorine. What happens? The exchangeable OH minus ions exchange from the resin and replace the outside. So that means ROH reacts with the chlorine to give a RCl. RCl. That means the region is captured with a Cl and the releasing of the OH minus ions. So if the place of chloride ions, if you have the water containing sulfate ions, similarly, ROH reacts with the sulfate ions and to give a product region captured with sulfate ions R2SO4. R2SO4. So this R2SO4 by balancing the chemical equation, 2 moles of the anion exchange region ROH reacts with the SO4 2 minus to give a R2SO4. Releasing. Why? Because permanent hardness is nothing but a the chlorides, sulfates, nitrates salts of a calcium and magnesium. Whereas temporary hardness is nothing but the carbonates and bicarbonates salts of a calcium and magnesium. So the third equation represents the temporary hardness removed. That means these carbonate ions reacts with the anion exchanger to give a R2CO3 product. By balancing the chemical equation, 2 moles of the ROH anion exchanger reacts with the carbonate ions to give R2CO3 plus 2 moles of the OH minus ions. 2 moles of the OH minus ions. So finally understood that whether it is cationic hardness is removed by the cation exchanger, and if it is anion exchanger, it is removed by the anion exchanger. That means cationic hardness removed by the cation exchanger and anionic hardness is removed by the anionic exchanger. Okay, ma? So finally, from the cation exchanger, we observe the H plus answer released water, whereas anionic exchanger exchanging of the anionic hardness and releasing the water containing a OH minus ions. So these H plus answer released from the cation exchanger and OH minus answer coming from a anion exchanger. Finally, these two ions, what are the ions? H plus ions coming from cation, OH minus ions coming from anion, combined with each other to give a water molecule. So that resultant water called as a demineralized water or deionized water. Why? Because after the treatment of cation exchanger and anion exchanger, the resultant water containing a exactly pH equal to 7. So that is called neutral water. So neutral water means the sample of the water which is free from all the dissolved salts and all the demineralized minerals. So all the minerals and all the ions. So that's why this is called deionized or demineralized water. So that is the process of the deionization or demineralization process. Okay, that is the previous topic. Now we discuss about the regeneration of the both the cation exchanger and the anion exchanger. So for example, if you filter the hard water up to 1000 liters or more than 2000 liters, what happens? The capability of the resins will be gradually decreases. So at this condition, we said that the life of the resin is over. That means the capability of the resin is over. At that moment, that resultant resin, that may be either cation exchanger or anion exchanger, is called as a exhausted resin. Exhausted resin. Okay, so that means the capability of the resin is over and it is need to go regeneration. Regeneration. So in the previous equation, we see the cation exchanger filled with the cationic hardness and anion exchanger filled with the anionic hardness. So these are the products. Now by taking these products and the regeneration takes place. So initially we regenerate the cation exchanger. So cation exchanger always regenerate with dilute hydrochloric acid. Dilute hydrochloric acid. Whereas anion exchanger always regenerated with dilute sodium hydroxide. Dilute sodium hydroxide. So for example, if you can take as the products of the previous cation exchanger, that is either R2Ca or R2Mg. For example, R2Ca reacted with the hydrochloric acid. Because the regeneration chemical is the The regeneration chemical is the hydrochloric acid. So that means R2Ca reacts with the hydrochloric acid to give a refreshed cation exchange reagent, that is equal to RH, and the byproduct is calcium chloride, CaCl2. So by balancing the chemical equation, this R2Ca reacts with the 2 moles of the hydrochloric acid, 2 moles of the hydrochloric acid to give a 2 moles of the RH. That means refreshed cation exchange region. Or for example, we consider R2Mg. That means that cation exchange region captured with the magnesium impurity. That means magnesium hardness, and it is also reacts with the hydrochloric acid to give a RH, and the byproduct is the magnesium chloride. Now the 2 molecules of chlorine is present. So by balancing the chemical equation, this cation exchanger R2Mg reacts with the 2 moles of the hydrochloric acid to give 2 moles of the RH plus MgCl2. So we observe these two equations. We regenerate the cation exchanger. From the equation, we understood that cation exchange region is regeneration takes place with the help of dilute hydrochloric acid. Now we consider the regeneration of the anion exchange region. So anion exchange region is regenerated by the dilute sodium hydroxide. Sodium hydroxide. Okay, ma. So for example, if you can take as previous anion exchanger products, so that is either RCl, or R2SO4, or R2CO3. These three are the examples for a anion exchange regions products. Consider R2SO4. Why? Because resin is filled with the sulfate hardness, and it reacts with the sodium hydroxide to give a ROH. ROH means refreshed anion exchange region, regenerated anion exchange region, and byproduct is the Na2SO4. So by balancing the chemical equation, this anion exchanger R2SO4 reacts with the 2 moles of the NaOH, 2 moles of the NaOH to give a 2 moles of the ROH plus Na2SO4. Or we consider a dust anion exchange resin filled with chlorine hardness, that means RCl reacts with the soda hydroxide to give a product like ROH, and byproduct is NaCl. Okay, NaCl. So we observed that RCl reacts with the 2 moles of the NaOH to give a refreshed region ROH plus NaCl. I think second equation is not balanced. Why? Because RCl reacts with the NaOH to give ROH and NaCl. There is no need of 2 moles of NaOH. Okay. Now RCl reacts with the NaOH to give a ROH plus NaCl. Okay, and we observe that in each and every regeneration, that may be either cation exchange region or anion exchange region, the byproducts are the salts like calcium chloride, magnesium chloride, sodium sulfate, and sodium chloride. So all these salts are removed by the washed with distilled water. All these salts, that may be either calcium salts, magnesium salts, sodium salts, all these salts are removed by the washed with distilled water. Okay, ma. So this is about the regeneration of the both cation exchange region and anion exchange region. Okay, ma. Okay, ma. All of you understood the regeneration process? Ma, all of you understood regeneration process?
Yes, sir.
Okay. Okay, ma. This is the overall diagram of a ion exchange process. Okay, ma. So with the help of this picture, I revised the overall ion exchange process, including regeneration. So initially what happens, the sample of the hard water, whether you take from either surface water or groundwater, but compared to surface water, the groundwater having so many salts. So that hard water is introduced in the first column. The first column is nothing but a cation exchanger. So that means it removes the cationic hardness from the sample of the water. Okay, ma. So what is the representation of cation exchanger, ma?
RH.
RH. So we see the equations. RH reacts with the calcium and how to give the R2Ca with the byproduct of the H plus ions. So the resultant water containing a presence of H plus ions. So presence of H plus ions means that resultant water having a lower pH value, and that resultant water again introduced into a second column. So that second column is nothing but a anion exchanger. What is the representation for anion exchanger, amma?
ROH.
ROH. So we see the equation also anion exchanger ROH, and how to remove the anionic hardness like chlorides, sulfates, nitrates. Okay, ma. So by the resultant water, it should be free from the all the dissolved cations and anions. So there are resultant water should be exactly pH equal to 7. So that pH 7 means the resultant water is nothing but a neutral water or soft water. The resultant water is called as a neutral water or soft water. Okay, ma. So after the completion of this cation exchanger work and anion exchanger work, some time gap, what happens? The exchangeable capacity of the exchange capacity of the cation exchange or anion exchange is over. At that moment, these regions are called as a exhausted regions. These regions are called as a exhausted regions. Okay, ma. At that time, there is a need to go regeneration process. Okay, ma. Both cation exchange agents and anion exchange. Okay, ma. Tell me what is the chemical used for cation exchange agent, ma? Regeneration purpose. What is the chemical used for regeneration process for cation exchanger?
HCl.
Dilute hydrochloric.
Dilute HCl.
Okay, ma, very good. So by using dilute hydrochloric acid, what happens? The impurities present in the cation exchanger will be removed and regeneration takes place. And what is the chemical used for anion exchanger, ma?
Dilute sodium hydroxide.
Okay, ma, dilute sodium hydroxide. So with the help of the sodium hydroxide, the anion exchanger is also refreshed and regeneration takes place. So this is the overall process of the ion exchange, including regeneration. Now we see what are the advantages and disadvantages of the ion exchange process. So the first advantage is the resultant water is containing almost all very low residual hardness. So that is nearly equal to 2 ppm parts per million, and the process can also be used for both acidic and alkaline water. That means it removes both acidic impurities and alkaline. Very high. That means Okay, ma, sorry for the interruption because Wi-Fi problem. So advantage, it removes the both cations and anions. Now we see what are the disadvantages of a ion exchange process. So the process is expensive because it contains both the cation exchange agents and anion exchange agents. And if the water containing a turbid as an impurity, that cannot be reduced by the ion exchange process. Further, it decreases the efficiency of a process. So it should be applicable to only ionizable impurities, especially salt. Why? Because the salt containing both cations and anions, and this process should not be applicable to non-ionizable impurities, just like a turbid impurity. Okay, ma? So this is about the advantages and disadvantages of a ion exchange process. Okay, ma? Tell me, what are the advantages of a ion exchange process? What is the resultant hardness of water?
2 ppm.
2 ppm. Okay, ma, the resultant hardness decreases up to 2 ppm. What is the second advantage, ma?
Highly acidic or alkaline.
Okay, so this process is useful for the to soften the highly acidic and alkaline water. Okay, ma, and what is the third advantage, ma? Third advantage, ma.
Removes all cations and anions.
Okay, should not be applicable to not only a single ions, applicable to both cations and anions. Okay, ma.
Yeah.
And what are the disadvantages of ion exchange process, ma?
Expensive.
The process is expensive because of it requires both cation exchanger and anion exchanger, including equipment. And what is the another disadvantage, ma? Another disadvantage, all types of waters impurities can be removed by ion exchange process, or any not 2 and 726 participants ఉన్నారు కదమ్మా. Seven not 2. మా 7 not 2 ఉన్నావు నువ్వు?
Yes, sir.
726.
Yes, sir.
ఇద్దరు ఉన్నారు కదా.
ఉన్నాం సార్.
నువ్వు నీ డొమైన్ మెయిల్ తో జాయిన్ అవ్వలేదా? 726.
డొమైన్ మెయిల్ తోనే జాయిన్ అయ్యాను కానీ నేమ్ రీనేమ్ చేసుకోవడం మర్చిపోయాను సార్.
ఓకే అమ్మా, చూడమ్మా రీనేమ్ చేయి.
ఓకే సార్.
Okay, ma, tell me, what is the second disadvantage of ion exchange process? What is the second disadvantage, Amma?
Decreases the efficiency.
For which type of water?
Turbid water.
Okay, Amma, very good. Turbid water decreases the efficiency.
కార్యకలాపాలకు అనుమతి ఇవ్వాలని నిర్ణయం తీసుకున్నారు.
Okay, Amma, especially turbid water decreases the efficiency of the process, Amma. Okay, Amma, so this is about the disadvantage of a ion exchange process. So this is about a external treatment method. Example is ion exchange process. Emma, now the ion exchange process is over. After the completion of a ion exchange process, next we enter into a desalination process as per our syllabus. And the example for a desalination process is the reverse osmosis. Okay, Amma, all of you understood ion exchange process, Amma? Amma, give me response. All of you understood ion exchange process?
Yes, sir.
Okay, Amma. Next, we enter into a desalination process. Amma, all of you visible desalination PPT, Amma?
Yes, sir. Yes, sir.
Okay, Amma? Okay. So first of all, desalination. So desalination means from the title, we understood that the process involves removal of common salt, from the sample of the water. Mainly the process involves the removal of the salt from the sample of the water. So that is called desalination. So by taking the example of the common salt. So what is the example for common salt, Amma?
NaCl.
Okay,
Cl.
very good. Sodium chloride. Okay, ma. So depending upon the type of the salts or the content of the salts present in the water, it can be classified into mainly three types. Ma. So that is fresh water, brackish water, and seawater. So it is purely depends upon the concentration of the solids present in the water. So first one is the fresh water. Fresh water means it is having less than 1000 ppm of the dissolved solids. It is having less than 1000 ppm of the dissolved solids. And the second one is the brackish water. Brackish water means it is having in between 1000 ppm to 35,000 ppm of the dissolved solids. And the third category is the seawater. Seawater means it contains having more than 35,000 parts per million percentage of the solids. So this is about the classification of the water based on the salt content. Okay, ma? So this is about the total 3 types. Okay, ma? Tell me how many types present on the based on salt content, amma?
ఏం చేస్తున్నావు? తింటున్నావా? క్లాస్ మధ్యలో తింటున్నావా?
లైట్ ఫిక్స్ వింటున్నాను క్లాస్.
Hello, am I audible to you, Amma?
Audible, sir, audible.
Okay, all of you visible my PPT, Amma?
Yes, sir.
Visible, sir, visible.
Okay, Amma, tell me how many types of water based on solid content? See the PPT, Amma, how many types are there?
3 types.
3 types. Amma, response yourself. So 3 types.
3 types.
What are they?
Fresh water.
Fresh water, brackish water, seawater.
Okay, Amma. Fresh water means how much solid content?
Less than 1000 ppm.
Okay, Amma. Brackish?
Greater than 1000.
1000 to 35,000 ppm.
35,000.
Seawater means
Greater than 35,000.
more than 35,000 ppm. Okay, Amma. So this is about the classification of the water based on solid content. Now we see water containing higher concentration of the salts is called as a brackish water. Due to the presence of large quantity of the salts, it is salty in taste and it is unfit for either domestic and industrial purpose. So the water can be put to good use by removing the salts from the substance, and the process used for the removal of the salts from the water is called as a desalination process. So this is the definition of the process used for removal of salts from the water is called a desalination process. And there are so many techniques used for a desalination process. Out of all techniques, the best technique is the reverse osmosis and electrodialysis. Reverse osmosis and electrodialysis. So as per our syllabus, we have only reverse osmosis. Okay, Amma, tell me what is the definition for desalination?
Removing the salt content, sir.
Okay, removes of the salt content from the sample of the water. Very good. What are the techniques used for desalination? What are the techniques used for desalination, Amma?
Reverse osmosis.
Reverse osmosis and electrodialysis. Okay, very good. Now we start as per our syllabus, we have only reverse osmosis. Let us start the technique reverse osmosis. So before knowing about the reverse osmosis, first we learn about the basic, that is called a string. Okay, so first of all, osmosis. Osmosis is defined as the process of spontaneous flow. The process of spontaneous flow of solvent molecules from lower concentration to higher concentration. These two concentrations are separated by a semi-permeable membrane. Okay, ma? So osmosis is defined as the process of spontaneous flow of the solvent the process of solvent, the process of solvent, the process of spontaneous flow of the solvent through a semi-permeable membrane from a dilute solution to concentrated solution. That means from lower concentration to higher concentration. So remember this point. Osmosis is defined as the flow of the solvent from the lower concentration to higher concentration, from lower concentration to higher concentration when both are separated by a semi-permeable membrane. Okay, ma? So for the flow of this solvent, some pressure is needed. That pressure is called as osmotic pressure. So the diffusion of the solvent particles takes place on the account of the hydrostatic pressure called as osmotic pressure, which drives solvent molecules in such of a equilibrium. So because of that osmotic pressure, that dissociated solvent molecules present in the equilibrium state. Next, see the reverse osmosis. So reverse osmosis. So reverse osmosis means there is an external pressure equal to osmotic pressure is applied on the concentration solution. Then the process of osmosis will stop. And if the external pressure exceeds, osmotic pressure, then solvent will be squeezed out from the concentrated solution. So that means it is reverse to the osmosis process, and that applied pressure, that means external pressure, is greater than the osmotic pressure, then the solvent moves from concentration solution to dilute solution. Then the solvent moves from concentration solution to dilute solution. So this process is called as reverse osmosis. Okay, amma? Previously I said that point is, remember, osmosis is nothing but a flow of the solvent molecules from dilute to concentrated, whereas reverse osmosis, the flow of the solvent molecules takes from concentrated to dilute solution. Okay, amma? So this is about the osmosis slide. Osmosis is nothing but a one of the qualitative property, and which involves the spontaneous flow of the solvent from lower concentration to higher concentration when both are separated by a semi-permeable membrane. So that is called osmosis process. And the diffusion of the solvent particles takes place on the account of hydrostatic pressure. So that pressure is called as a osmotic pressure. And mainly the osmotic pressure role is which drives the to maintain the that dissociated solvent molecules present in the equilibrium state. Okay, ma? So this is about the osmosis and osmotic pressure. Amma, all of you visible this osmosis slide, amma?
No, sir.
No, sir.
No, sir. No visible.
Okay, ma, 1 minute, wait. Okay, ma, now it is visible.
Yes, sir.
Yes, sir. Now visible.
Okay, ma. So see the osmosis and osmotic pressure. So osmosis is nothing but it is defined as the flow of the solvent molecules, from lower concentration to higher concentration. The flow of the solvent molecules takes place from lower concentration to higher concentration when both are separated by a semi-permeable membrane. And because of this movement, what happens? The diffusion of the solvent particles takes place. On the account of hydrostatic pressure. So that hydrostatic pressure is called as a osmotic pressure. And the role of that osmotic pressure is to maintain the equilibrium within the dissociated solvent particles, in the dissociated solvent particles. Next, we see reverse osmosis. So reverse osmosis means if you apply the actional pressure on the concentration side, what happens? That pressure is exceeds the osmotic pressure. Then what happens? The flow of the solvent is reversed. In case of osmosis, from lower to higher concentration. But in reverse osmosis, we apply the actional pressure that is greater than the osmotic pressure. Then what happens? Flow of the solvent takes place from higher concentration to lower concentration. So that process is called as a reverse osmosis. So for the better understanding purpose, in the next slide, we see the diagrams for both osmosis and reverse osmosis. Okay, ma. So this is the diagrams for both osmosis and reverse osmosis. Okay, ma. All of you visible the diagrams?
Yes, sir.
Okay. So the first diagram, that means the left side diagram represents the osmosis and right side diagram represents the reverse osmosis. Okay, ma. First we see the definition of osmosis. So what is osmosis, ma?
Movement of solvent particles from high concentration to low concentration.
See the diagram, amma. Left side diagram is osmosis. So direction of water flow. It means it on the children, lower to higher on the higher to lower on the
Lower to higher.
Lower to higher, sir.
lower to higher means osmosis. Higher to lower on reverse
Reverse
osmosis.
osmosis.
Okay, ma. Okay, again I explain. So the flow of the water molecules or the flow of the solvent molecules from lower concentration to higher concentration, when both are separated by a semi-permeable membrane, that means in this case the actional pressure is less than the osmotic pressure. This condition is important. Actional pressure is less than the osmotic pressure. Okay, and in reverse osmosis, what happens? The flow of the solvent molecules takes place from higher concentration to lower concentration, when both are separated by a semi-permeable membrane. And what is the condition? Actional pressure is greater than the osmotic pressure. Okay, ma. So this is the reverse osmosis. And how much that actional pressure is required? Nearly 10 to 14 kg per centimeter square. So that is the actional pressure is required for the reverse osmosis. Then only the flow of the solvent molecules takes place from higher concentration to lower concentration, when both are separated by a semi-permeable membrane. Okay, ma? So this is about the osmosis and reverse osmosis. Okay, ma? Now tell me, what is osmosis, ma?
Flow of particles from lower concentration to higher concentration.
Okay, ma. And condition when both are separated by a
Semi-permeable membrane.
You mentioned that point also. Okay, ma. What is the pressure?
Osmotic pressure.
Okay, ma. Osmotic pressure is required, and the condition is external pressure is less than the osmotic pressure. And what is reverse osmosis, ma?
It flows from higher to lower.
Okay, the flow of the
semi-permeable membrane.
The flow of the solvent molecules takes place from higher concentration to lower concentration when both are separated by
Semi-permeable
separated by semi-permeable membrane. Okay, ma. And what is the condition, ma?
External pressure is greater.
External pressure is greater than osmotic pressure. How much external pressure is required, ma? Emma, how much external pressure is required? 10 to 14 kg per centimeter square. 10 to 14 kg per centimeter square. So that amount of the external pressure is required for reverse osmosis. Okay, ma? Okay. So in both diagrams, either it is osmosis or reverse osmosis, what is the common point, ma?
Semi-permeable.
Very good, Amma. Semi-permeable membrane. So for the process of either osmosis or reverse osmosis, this part is very, very important. Semi-permeable membrane. Now we discuss about semi-permeable membrane. Okay, ma. So because of the importance of the semi-permeable membrane, it is manufactured with the generally not only ordinary chemicals, it is made with the special chemicals. So that chemicals are the cellulose acetate, polymethaacrylate or polyamide polymers. Okay, ma. Cellulose acetate, polymethaacrylate or polyamide polymers. Okay, ma. And in the reverse osmosis, pure water is separated from its contaminants rather than removing of the contaminants from the water. And the process is also called as ultrafiltration or superfiltration process. This process is also called as superfiltration or ultrafiltration process. Okay, ma. Tell me, what are the chemicals used for manufacturing of semi-permeable membrane, ma?
Cellulose acetate, polyamides, polymers.
Polymethaacrylate, polyamide polymers. Okay, ma. What are the alternative name for reverse osmosis, ma?
Superfiltration, hyperfiltration.
Okay, very good. So this is about the overall osmosis and reverse osmosis process. Next, we see what are the advantages and disadvantages of a osmosis and reverse osmosis. So first of all, we see the advantages. So generally this process involves the almost all the ionizable ions, and not only ionizable ions, even it removes the non-ionizable ions. Non-ionizable ions. Non-ionizable ions means like microorganisms and some of the organic chemicals present in the water. Even such like impurities also removed from the reverse osmosis. So that's why you see the advantage. This process removes lead, calcium, magnesium, sodium, potassium, aluminum, all of these cations. And the next one, chloride, nitrate, fluoride, sulfate, boron, all of these nothing but anions. After that, we see this process not only to remove ionizable ions like cations and anions, and it is also applicable to like most microorganisms. Microorganisms nothing but non-ionizable impurities and organic chemicals. So organic chemicals also some of the non-ionizable formulas. So even though the compound is non-ionizable, the substance is non-ionizable, that impurities also removed from the reverse osmosis. So that is the advantage of reverse osmosis compared to a ion exchange process. And what is the disadvantage? This process mainly requires the large volume of water, and finally it releases a high volume of the wastewater. It is difficult to maintain that large amount of the waste water. Okay, ma? So that is about the disadvantage of a reverse osmosis. Okay, ma. Tell me what are the advantages and disadvantages of reverse osmosis, ma? Ma, what are the advantages and disadvantages of reverse osmosis, ma? Ma, give me response. What are the advantages and disadvantages of reverse osmosis?
It removes lead, calcium, magnesium, sodium, potassium.
Okay, I want what is the difference between ion exchange and reverse osmosis? Previously, we see ion exchange process. Now we discuss about the reverse osmosis. Out of two, which one is more advantage?
Reverse osmosis.
Why reverse osmosis is more advantageous compared to ion exchange?
Sir, ion exchange removes only the cations, sir.
Only cations.
In
What
reverse
about anions?
osmosis,
Removes only the ions, sir, cations or anions. This removes others also.
Ion exchange process removes only ionizable ions, whereas reverse osmosis removes the both ionizable and non-ionizable ions. Okay, ma. So that is the advantage of the reverse osmosis. And what is the disadvantage, ma?
volume of the water will get wasted and difficult to manage.
Okay, so difficult to manage the wastewater coming out from a reverse osmosis process. Okay, ma. So this is about the advantage and disadvantage of a reverse osmosis. Okay, ma. Now all of you understood the both ion exchange process and reverse osmosis process.
Yes, sir.
Okay, ma. Just wait, Amma. We watch the syllabus. Okay, Amma. All of you visible the syllabus page, Amma?
Visible, sir, visible.
Yes, sir. Yes, sir.
Okay, Amma. So
Yes,
see
sir.
the syllabus. Our syllabus of module is almost all over. Initially, we discuss about introduction to water, nothing but sources. After that, we see the parameter, nothing but hardness of the water. Then we see what are the causes of the hardness of the water. After that, we see types like temporary and permanent hardness. After that, we see how to express the hardness, including its units. Then we determine the hardness of the water by using complexometric method with the help of the chelating agent EDTA, ethylene diamine tetraestic acid. Next, we see what is the potable water and what are the required parameters for the potable water and what are the steps involved to get a potable water by using municipal water treatment, and especially designification by the chlorination and ozonization process. Next, finally, we end the module 2 with the external treatment water ion exchange process and desalination of the water. So the example for the external treatment is ion exchange, and example for a desalination is reverse osmosis. Already in the offline classes, we dictate the numerical problems and we know how to determine the hardness of the water. Even salts are given, and by using titrometric analysis, EDTA. Totally 7 problems are there. Already I discussed about those problems in offline classes. Okay, Amma? Now this is about the module 2 syllabus. Anybody having doubt, Amma, in this module 2?
No, sir.
Okay. All of you understood overall topics?
Yes, sir.
Yes, sir.
Okay, Amma. Don't lazy. Be active.
Chandu.
Okay, Amma. Now we move to question bank of module 2. Okay, Amma. All of you visible the question bank, Amma?
Yes, sir.
Okay, Amma. So already you discuss about in the module 1 question bank. We know about the what are the questions present in the question bank pattern. There are totally 3 patterns: part A, part B, and part C. So part A is nothing but a short answer questions. So now we see one by one. First one is the define hardness of the water. Define hardness of the water. So I think all of you know about the hardness. The sample of the water which doesn't give the lather with soap, that is called hard water. If the water containing that hardness is called as a hardness of a water. Okay, ma? The sample of the water which doesn't give lather with soap. And what is the compare temporary and permanent hardness of the water? Temporary and permanent hardness. Tell me what about temporary hardness, Amma?
Which can be removed easily with which can be
removed by boiling process, Amma. Okay, Amma. Whereas permanent hardness can be removed by boiling.
Hardness.
Is it possible?
Ion exchange method.
ion exchangeable.
Very good, Amma. Ion exchange method. Ion exchange method means comes under category of the water softening methods. Water softening methods. Okay, Amma. And temporary hardness is mainly caused by the bicarbonate salts of calcium and magnesium. Bicarbonates, carbonates, hydroxides salts of calcium and magnesium. Whereas permanent hardness is caused by which salts?
Chlorides, anions, chlorides, sulfates,
Nitrate.
nitrates.
Very good. Chlorides, sulfates, nitrates of calcium and magnesium. And third question, what is the basic principle involved in the estimation of hardness of water by EDTA method? EDTA method. Already we discussed about this method. What is the principle, Amma? At least what is the method, Amma? What is the method for the determination of hardness of water?
Complexometric method.
Okay, Amma, very good. Complexometric method. So in this complexometric method, initially what happens? The hard water is treated with a indicator, nothing but EBT indicator, Erichrome black tea. Finally, it forms a metal indicator complex. So that metal indicator complex is treated with a chelating agent EDTA, ethylene diamine tetraestic acid. So that EDTA having ability to replace the indicator from the metal. So finally, it gives a metal EDTA complex and the releasing of the indicator. So metal indicator complex is a wine red color and the releasing indicator is a blue color. So the color changes from wine red to blue. Finally, you observe that metal EDTA complex. Metal EDTA complex. So that metal EDTA complex is gives the quantity of a total hardness present in a water. So that is called as a complexometric method. Why it is called complexometric method? The product is in the form of a complex. See the okay, ma. All of you visible the equation, ma?
All of us visible, sir.
Okay, ma. So initially the metal ions present in the hard water treated with the indicator EBT and it give a metal indicator complex. Metal indicator complex. So this metal indicator complex treated with a EDTA to give a metal EDTA complex. Metal EDTA complex. So from the metal EDTA complex, we determine the amount of the hardness present in the water sample, both total hardness and temporary hardness and permanent hardness within the ppm range. Okay, ma? So this is about the principle involved in the complexometric method, complex geometric method. So this is the principal equation. Okay, Amma. All of you visible the question bank PPT, Amma?
Yes, sir.
Okay, Amma. So third question is over. Next to fourth question. Define ppm and degree Clark. Define ppm and degree Clark. ppm means million, means how much, Amma?
10 lakh.
Million means 10 lakh. That means 10 power 6. ppm means parts per million. Parts per million. That means we determine the hardness present in the water within the parts per million level. So that means we represent the that hardness up to 6th decimal, up to 6th decimal. So that is called ppm, parts per million. Next one, degree Clark. Degree Clark means we represent the that amount of the hardness within 1:70,000 parts. 1:70,000 parts. That means 0.07 Clark degree. And we have the relation 1 ppm is equal to 1 milligram per liter is equal to 0.07 Clark degree is equal to 0.1 French degree. 0.1 French degree. So these are the units of a hardness of a water. Next we see define milligram per liter and degree French. Already discussed about milligram per liter. Milligram per liter, it should be equal to a 1 ppm, and degree French should be equal to 1 ppm is equal to 0.1 French degree. Okay, next, what are the disadvantages of a hard water? What are the disadvantages of a hard water? Okay, anybody tell me what are the disadvantages of hard water?
It doesn't give lather with soap.
Okay, it doesn't give lather with soap. That is the definition, Amma. What are the disadvantages? Tell me any domestic disadvantage or industrial disadvantage. If you use hard water for the cooking purpose, what happens? It is boiled rapidly or slowly? Or if you drink the hard water, what happens?
Causes diseases.
Causing diseases. But because the hard water containing a salts of calcium and magnesium. So these salts like calcium and magnesium forms a complex with the acetate ions. That means to form a it forms a complex with acetate and oxalate ions. Oxalates are mainly present in like lemons and tomatoes. So these oxalates, when you take in a eating of it like tomatoes or lemons or any orange like juices, that juices containing a oxalate ions, that oxalate ions forms a complexes with calcium and magnesium. Finally, these convert into a stones in our bodies, especially at the place of kidneys and gallbladder. So that is the disadvantage of the hard water. And second disadvantage is if you use the hard water for the cooking purpose, it is not boiled rapidly and it takes so much of the time. That means gas consumption takes place. Gas consumption takes place. And compare soft water and hard water. Compare soft water and hard water. Emma, tell me what is the definition for soft water, Amma?
It removes the hardness and makes leather.
Soft water. Soft water.
Forms
Yes.
lather with soap.
Which
Ah, The sample of the water which give lather with soap, that is called salt water. The sample of the water which doesn't give the lather with soap, that is called hard water. Okay, ma? Next, what is soft water? Gives the examples of any two soft water sources. Soft water sources, amma.
Rainwater, sir.
Very good, amma. Rainwater is the example for a soft water. And next one is
Surface water.
surface water is also contains
Distilled water, sir.
deionized water or distilled water. We get from which process, amma?
Boiling process.
Boiling process or ion exchange process?
Ionic.
Ionics.
Ion exchange process. Okay, amma. Next, ninth question. How permanent hardness is removed from hard water? Permanent hardness is removed from hard water.
Sulfates.
Softening the metal.
By sulfate.
That methods are called as which methods?
Ion exchange.
Ion exchange process or reverse osmosis. All of these comes under category of the water softening methods. Called as simply water softening methods. Okay, ma? Okay, and 10th question is list the salts responsible for the temporary and permanent hardness of the water. Okay, ma? First we see temporary hardness. Yeah, tell me. Temporary hardness
Calcium
causes
salts of bicarbonates and carbonates
Magnesium and calcium.
of calcium and magnesium.
Okay, ma. That means calcium carbonate, calcium bicarbonate, magnesium carbonate, and magnesium bicarbonate. All of these salts cause a temporary hardness. What about permanent hardness, amma?
Sulfates.
Sulfate, chloride.
Sulfates.
Nitrate.
Okay, ma. That means calcium sulfate, calcium chloride, calcium nitrate, and magnesium sulfate, magnesium chloride, magnesium nitrate. All of these salts causes the permanent hardness. Okay, ma. Next, what is meant by treatment of water?
Purification of.
Purification of a water. Okay, ma? So we see the mainly 4 steps involved in the treatment of water, that is screening, sedimentation, filtration, and designification. Okay, ma? Next, define softening of water.
Removal of hardness causing salts from water.
Removal of hardness caused salts from the sample of the water, that is called softening of the water. Okay, very good. Next, second question. How is natural water is sterilized by the bleaching powder? By bleaching powder. Already we see in a designification process. So what is the formula for bleaching powder, amma? CaOCl2, calcium oxychloride. So whenever this calcium oxychloride reacts with the water, what are the products are observed? Mainly hydrochloric acid and hypochlorous acid, HCl and hypochlorous acid. What is the formula for hypochlorous acid, amma? HOCl. So further, this hypochlorous acid dissociates into H plus and OCl minus. So this OCl minus kills that pathogenic bacteria present in the water. So the disinfectant is the hypochlorous acid. So that is the sterilization taken by bleaching powder. Okay, ma? Next one. 4th question. Explain breakpoint chlorination in treatment of the potable water. So breakpoint chlorination. So first of all, breakpoint chlorination means the point at which free residual chlorine is available. That means at that point we observe the almost all the pathogenic bacteria is killed by that disinfectant, nothing but chlorination process. That means it tells about the how much amount of the chlorine is required, how much amount of the chlorine is required for the designification process, that is called breakpoint chlorination. Okay, ma, we see the diagram. Okay, amma, all of you visible the breakpoint chlorination diagram, amma?
Yes, sir.
Okay, amma. So this breakpoint chlorination is in between the residual and chlorine added, and it contains a totally 4 parts. In between 1 and 2 parts, that chlorine is destroyed by the reducing compounds, and in between 2 and 3 parts, we observe the formation of chloroorganics and chloramines, and in between 3 and 4, we observe the chloroorganics and chloramines destroyed. And after the 4th point, we observe the residual chlorine. That means that point available chlorine, free available chlorine. So after the 4th line, we see chlorine is formed. That means at the point of the chlorine is completely destroyed the pathogenic bacteria. So this tells about the from the graph is nothing but breakpoint chlorination. So it is simply tells about the point at which free residual chlorine begins to appear is termed as breakpoint chlorination. And this breakpoint chlorination, whether the chlorine is further added or not, so that is called a break chlorination. Okay, ma. So this is about the breakpoint chlorination, 4th question. And next one is the 15th question. Explain the reverse osmosis process to produce a potable water. Explain the reverse to produce a potable water. Just we discuss about today potable reverse osmosis process. Okay, ma. Anybody tell me what is the definition for reverse osmosis?
The movement of solvent particles from higher concentration.
Movement of water particles from higher concentration to lower concentration.
From higher concentration to
In
lower
the presence of the
concentration.
permeable, in the presence of
Ah.
semi-permeable membrane.
When both are separated by a semi-permeable membrane.
Bye, sir.
Okay. Number 3, amma. think the attendance is recorded in Zoom login amma in reports,
You can
and
tell.
I am taking the attendance from the Zoom Zoom reports. Thank you.
Bye, sir. Thank you. Okay.